Hello everyone, so in this video we will be discussing about atomic structure, which is the unit 2 of our subject for this semester. So let's proceed for question 1. So the diagram shows the structure of an atom of element X. So looking at the atom, so it has 3 orbitals. So in the middle, which represents the nucleus contains the number of protons and neutrons. So, and the number of protons tells us the atomic number of an atom. Alright? So, apart from that, elements are also identified through their atomic number, which determines the number of electrons present. So, there are 5 protons and expected that there are also 5 electrons in a electrically neutral element or electrically neutral atom. This determines as well the element's position in the periodic table. Now looking at the options, we have boron, carbon, sodium, and sulfur. And as we can see, we know that element 5 in the periodic table is boron. Hence, the answer is boron. B, C, and D are incorrect as these elements have different atomic numbers and are not represented by the diagram. Question 2. Which elements about a phosphorus atom are correct? Alright, so we have 3115. So first statement, the nucleon number is 16. Now, statement 1 for me is incorrect. Why is that? The nucleon number of the element is the number of protons and neutrons added together, which in this case of phosphorus, it is 31. Alright? So, 31 is what we call the nucleon number. Okay? Nucleon number. So, it's 31, not 16. Statement 2, the number of outer electrons is 5. In this case, this is correct. Why? As the electronic structure of phosphorus is, so electronic configuration, so the first, the 2, 8, and then 5. Because its atomic number, the number of electrons it has is 15. Correct, 15, so 285. So this is correct. Now, statement 3 is the proton number is 15. Yeah, this is also correct. Hence, the two statements that are correct are 2 and 3. And that is shown in letter D. So the answer is D. Question 3. Which statement about atoms is correct? A. Atoms contain protons and electrons in the nucleus. B. Neutrons are negatively charged. C. Protons are positively charged. And D. The nucleon number is the number of neutrons. The proton is positively charged, a subatomic particle which is found inside the nucleus. So, therefore, the answer is C. A is incorrect because electrons are found in the shells located outside the nucleus. Okay? Just like the phosphorus just now. So if the lines that I've shown here are the shells, it's represented by a circle. If you remember, I've drawn this on the board. So we have circles. Alright. It doesn't show. So we have circles there. Let me just manually draw it. So first circle, first orbital, second orbital, then third orbital. So in case of the phosphorus element, so there's 2 electrons here, then 2, 8, 5. So 8 electrons here. All right. And the outermost orbital shows us the the charge, not charge, the number of electrons found in the outermost shell. So that's why A is incorrect. Alright, letter A says atoms contains protons and electrons. No, protons and electrons are not in the nucleus. It's what's in the nucleus is actually protons and neutrons. Okay, and neutrons. Now for B, neutrons are negatively charged. Neutrons are actually uncharged. They are neutral particles. For D, the nucleon number is the number of neutrons. So I just said that in question 2, the nucleon number is the number of protons and neutrons added together. Okay, added together. So C is the correct answer for question 3. Now for question 4, what do the nuclei of hydrogen, so 1,1H atoms contain? A, electrons and neutrons, B, electrons and protons, C, neutrons only, and D, protons only. So hydrogen has 3 isotopes. We have the hydrogen itself. We have, I think I can draw this one. So hydrogen itself, it's actually it's a positive. And we have in the middle, it's 1 proton. So we call this the proton. So the middle, we call this proton. And the electron is in here. Alright. We call this the hydrogen atom. So, and copy, let's paste this one. So in this case, I'm pasting it because for its first isotope, in the middle, alright, in the middle, we call this second isotope as deuterium. Okay, deuterium. And in a deuterium, there's 1 proton and 1 neutron. So a plus 1. So let's put a circle here, I guess. So 1 proton and just P plus and neutron. Okay, that's for the deuterium. And we have also copy the third isotope, which is the tritium. Okay, tritium. Now in the tritium, instead of having 1 neutron in the middle, there's 1 proton and 2 neutrons. Okay, neutron and another neutron. Okay, but still the same number of electrons. Okay, neutrons there will be 2. Alright, so that's what the nuclei contains. Now the first isotope, protium or hydrogen, is the simplest of all elements. It consists of only 1 proton and 1 electron. So since it has no neutron, it is also the lightest element. A, B, and C are incorrect as the nuclei of protium or the hydrogen. So let me write that down. This one can be named as protium as well. Okay. The A, B, and C are incorrect as the nuclei of protium contain only 1 proton and nothing else. So therefore, the answer is D. Protons only. For question 5, the table below shows the nucleon number and the number of neutrons in one atom of isotopes W, X, Y, and Z. W, X, Y, and Z. Which statement about W, X, Y, and Z is correct? A. W and X are isotopes of the same element. B. X and Y are isotopes of elements in the same group of the periodic table. C. Y and Z are isotopes of elements in the same period of the periodic table. And D. Z has a higher proton number than Y. So we're determining which statement is correct. Let's analyze letter A. So first thing that we need to do here is to calculate the atomic number for each element by subtracting the number of neutrons from the nucleon and identify each element. Okay, so let's say W and X. So W and X are isotopes of the same element. So 35 minus 18. 35 minus 18. So 35 minus 18, it's 17. This is 17. And 37 minus 20 is 17. So in this case, they are both 17. So W and X have the same atomic number. So they are isotopes of the same element. And as far as I remember, 17 is, in the periodic table, is element chlorine. Okay? So that makes it true already. Hence, the answer is A. Now for B, since it's only asking for one statement, we can evaluate it. The X and Y are isotopes of elements in the same group of the periodic table. X and Y are isotopes of the same elements in the same group of the periodic table. I think this is incorrect, as X is chlorine and 39 minus 20 is 19, and that is argon, and they are not in the same group, so it's not correct. For C, so again, this is 19, and I believe this is argon. Here it's actually 22, which is again different. So Y and Z are isotopes of elements, so they're different. 18, this is 18, yeah. And Z has a higher proton number than Y. It's also incorrect, as the proton number Z is lower than that of Y. So there. Sometimes it will also save time if ever the question is asking which statement is correct, and from letter A itself you were able to determine that A is already correct. So sometimes you don't need to go B, C, and D if you think you're confident enough that A is already correct. So in this case, A is the correct statement. Question 6. The diagram shows the atomic structure of an element X. So again, when the atomic structure is given, automatically we take a look at the middle, which is the nucleus. Now in the nucleus of this structure, there are how many protons? So we have 1, 2, 3, 4. So there are 4 protons. Okay, maybe we can just put that in the label. So 4 protons. And the neutrons is 2, 3, 4, 5. Electrons as well is surely 4. Now, what is X? So technically, again, as I mentioned in the previous question, the number of protons tells us the atomic number of the atom. And in this case, it's 4. So just find, looking at your periodic table, just find the 4th element in the periodic table. In this case, we have beryllium. Okay, so the answer is beryllium for question 6. 7. Which statements comparing the properties of electrons, neutrons, and protons are correct? So we are determining 2 statements here. So the first column tells us that the neutrons and protons are both heavier than electrons. Second column, only electrons and neutrons are charged. So it seems even for the first statement itself, we know that neutrons doesn't have a charge. Okay, so eliminating the option, it's either the answer is either B or C already because it's X. So B, neutrons and protons are heavier than electrons. The mass of the electron is much less than that of the neutron and proton. Protons and electrons are charged, while neutrons are neutral. So going back to what we learned in the class, so for proton, okay, proton, the relative mass of a proton is 1, and its relative charge for a proton is 1 as well. For an electron, going back to what we have, the relative mass of electron is 1, and its relative charge is -1. Oh, sorry. The relative mass of electron is negligible. I forgot that one. So it's so small, so very small. So we can write negligible. Negligible. And its charge is -1, while neutron is 1. The relative mass is 1 and the relative charge is 0. It's neutral. And the location of proton, the location, it's in the nucleus. The electron, it's in shells, okay? In shells. So that's the one that I'm saying just now. So looking back at the previous question, we call this as shells, the circles. As shells or orbitals, all right? Or energy levels, okay? Energy levels. So take note of these words, they mean the same thing. And the neutron is found in the nucleus. All right. Now all this information, so evaluating letter B or letter C, neutrons and protons both are heavier than electrons. Of course, they are. It's true. So this is correct. I agree with this. This is incorrect. Hence, the answer is B. Okay? The answer is B. For question 8, the atomic structures of 4 particles are shown. So particles W, X, Y, and Z. So the number of electrons, neutrons, and protons for each element are also shown. Which 2 particles are isotopes? Now once again, isotopes are defined as atoms of the element with the same proton number but different nucleon number due to different numbers of neutrons in their nuclei. Now looking at this, W and X have the same number of neutrons. Okay, W and X have the same number of neutrons. So particle W has 1 neutron less than particle Y, but they both have the same atomic number. Okay, W and Y. Okay, yes it is. And option B is the only one which matches the definition of an isotope, because W and Y, because they have 8 here, 8 here as well, 8 protons, 8 neutrons, but this different number of electrons. Okay, so there, I think the answer here is W and Y, which is B. Okay, which is B. So they are isotopes. All right. Question 9. 2 atoms, X and Y, can be represented as shown. So as you can see, both of them is number 20. So we have the 20 is the atomic number, 45, alright. So which statement is not correct? A, X and Y are atoms of different elements. A is already the answer based from the statement because as you can see, both of them has 20. And it means they are the same element. So A is the answer. X and Y is the incorrect statement. But then let's evaluate the other options. So X and Y are isotopes. Yes, it's true. So elements are identified by their atomic number, so which is done in letter A. Okay, B is correct. C, X and Y have different mass numbers. Yes, it's correct because it indicates the different numbers of neutrons. Okay, 45 for Y and 41 for X. So they have different mass numbers. And D, X and Y have the same number of electrons, which is actually also correct because they have the same atomic number, then the number of electrons are also the same. Okay? So A is the answer. Question 10. An aluminium atom has a nucleon number of 27 and a proton number of 13. How many neutrons does this aluminium atom contain? A13, B14, C27, and D40. Now, you just need to take a look at your periodic table here so you can be helped. You can find the answer immediately. Now, the nucleon number once again represents the number of protons and neutrons added together in the nucleus. Now, in the question, the nucleon number is 27 and the proton number is 13. Then, we just need to subtract this one. So, 27 minus 13. And that gives us 14. So, 14 neutrons. So, so that's letter B. Alright, 11. An atom of element Q contains 19 electrons, 19 protons, and 20 neutrons. What is Q? Alright. So, the atomic number of an element is the number of protons in the nucleus. So, that's 19. That's element potassium. Now, the elements of the periodic table are placed in order of increasing atomic number. Just a gentle reminder to everyone. So you can immediately find the element. So potassium is the element with an atomic number 19. So there. Okay, potassium. Question 12. Okay, question 12. The table shows the atomic structure of 4 atoms. Which atom is not a metal? Element A has 18. So that element is argon. So it's a noble gas and it's not a metal. So it's a noble gas. For B, it has 19 protons. That is 19. And it's also 19 here. So meaning B and C are isotopes of one another. They're isotopes. Oh, we just had 19 in the previous question, right? Which is potassium. And both, so which is potassium, they are isotopes of the element, but both are metals. So both metals. The question is not a metal. So question 20 is calcium. Okay, calcium. So meaning D is the correct answer, is not a metal. Element D is part of group 2 metal. So Oh, it's a metal, right? So the question is not a metal. It's a noble gas. So the answer is A. I thought the question is a metal. Alright. So the question is not which atom is not a metal. So A. So from letter A itself, it's already the answer. So, yep. So A is the correct answer. So, yeah. Question 13. The diagram shows the structure of an atom. So in the middle again, we have 2 protons, 2 neutrons, 2 electrons. Okay, 2 electrons and 2 neutrons. Now, which diagram shows the structure of an isotope of this atom? Once again, isotopes are defined as atoms of the element with the same proton number but different nucleon number due to different numbers of neutrons in the nuclei. Now, option A has the same number of protons and electrons as the diagram, but different number of neutrons. So there, 2 protons, 1 different neutrons. So the answer is A. Unlike the other options. So there are 3 here, there are 3 here, there are 3 here. Hence, A is the correct answer. 14. Carbon has 3 naturally occurring isotopes. So carbon 12, carbon 13, and carbon 14. Which statement explains why the isotopes have the same chemical properties? Wow. So we have a lot of explanation to do here. So for A, they have the same number of electrons in the first shell. B, they have the same number of electrons in the outer shell. C, they have the same number of neutrons in the nucleus. And D, they have the same number of protons as neutrons. Okay, so once again, isotopes are defined as atoms of the same element with the same proton number but different nucleon number due to their different numbers of neutrons in their nuclei. Now, since they have the same atomic number, the number of electrons in each isotope is the same. Alright. The electrons are arranged in the same configuration, so they have the same number of outer electrons or valence electrons. And the number of outer shell electrons determines an element's chemistry. Therefore, isotopes display a similar chemistry as they have the same number of electrons in their outer shell. In letter A, it says they have the same number of electrons in the first shell, which means this is incorrect because the inner shell electrons have no effect on element's chemistry. B, they have the same number of electrons in the outer shell. So B is the correct answer. They have the same number of electrons in the outer shell. C says they have the same number of neutrons in the nucleus. C is incorrect, as even though isotopes of the same element have different numbers of neutrons, this has no effect on their chemical behavior. D says they have the same number of protons as neutrons. It's also incorrect. So whilst it is possible for an isotope to have the same number of protons as neutrons, such as carbon 12, which has 6 protons and 6 neutrons, 2 isotopes of the same element will not both have the same number of protons as neutrons. So, as the isotopes have different numbers of neutrons from one another. For example, carbon 13 has 6 protons and 7 neutrons. So, it's also incorrect. So, B is the correct answer for this question. Alright. Now, we'll now be moving on to section B. Section B is theory questions. So, for question 1A, complete the table which gives the names, symbols, relative masses, and relative charges of 3 subatomic particles. I think I've discussed this one in my previous slides. It's already here. Just need to input it. So we have electron. The symbol is E. So It's a negative. It could be, you can write E negative or E will do. Okay, or E will do. For proton, the symbol of proton has many. It could be P, it could be P plus, it could be the hydrogen atom. Alright. Neutron is just, it's N. So this one, the name is neutron. Okay, neutron. For relative mass electrons, relative mass is negligible or negligible, yeah, or 1 over 1/840. Okay, 1 over 1/840. Let me write that down properly. 1 over 1/840. Okay. There are many actually values, or you can just write negligible. I think Cambridge will accept this answer already. You don't need to write everything. It's just for the sake of explanation. The relative mass of proton is 1. The relative mass of a neutron is also 1. For the relative charge, electron is -1. And for proton, it's +1. I think that completes the table. Now we have how many unknowns here? We have 1, 2, 3, 4, 5, 6. It seems you don't need to answer this part. So 6 unknowns. To get 3 marks, you need to get all 3 correct. Yeah. Or sometimes Cambridge will check it per row. So if you gave all the correct information for electrons, then you get 1 mark. One mark for if you gave all the correct information for proton and then neutron. That gives you 3 marks. Now for B, use the information in the table to explain the following. Atoms contain charged particles, but they are electrically neutral because they have no overall charge. Alright. So you can say use the information in the table to explain. So again, the command word here is explain. So we have the 2. Alright, so we can say atoms have no overall charge. Yeah, because they have equal numbers, okay, equal numbers of protons and electrons. Okay, of positive and negative charges. Okay, or since there are 2 marks here, we can say the net charge is equal to 0. Okay, is equal to 0. Now atoms can form positive ions. Now when an atom forms a positive ion, they lose electron. Okay, so we can just say lose electrons. Alright. How many marks this? We have 2 marks, so we need to give 1 more point. So at 1, we can also say there are more because it's losing positive ions. There are more protons than electrons. Alright. So there, I think that's enough. And for question 3, atoms of the same element can have different masses. So atoms of the same, so meaning because this is an isotope, they have different numbers of neutrons. Okay, you have different number of neutrons. How many marks this? 2 marks, so you need to get 2 points. Isotopes have the same number of protons. Okay, so same number of protons. That's the second point. Or sometimes the same number of electrons. Okay, or same number of electrons. So this is a possible answer as well. Or actually, Cambridge will also accept they have different masses. If you wrote isotopes, they are isotopes. Since we're explaining, it's also acceptable answer. Now for question 4, part 4, scientists are certain that there are no undiscovered elements missing from the periodic table from hydrogen to lawrencium. Yes, because in the periodic table, it's already arranged, and an element is known for each proton number, right? So we can say an element is known for each proton number. Okay, proton number. All right. Yeah, because yes, I think that's enough. We can also mention the proton number of hydrogen, which is 1, and the proton number of lawrencium is in the periodic table is 103. So you can reason that out as well. All right. For question 2, the table gives the number of protons, neutrons, and electrons in atoms or ions. So in this question, it differs only from 1A by us giving the symbol or formula. Now in this case, we have to ensure as well to give the charge of some ions. Okay? So when the number of protons and electrons are not equal to each other, then we determine whether it's a positive ion or a negative ion, and by how many electrons. Now for B, the number of proton is 11. Okay, it's 11, and the number of electron is 11, so it's a neutral. And the element 11 in the periodic table is sodium. So sodium, and it has a atomic mass of 23 and 11, and that's it. For C, it has the same number of electrons and protons as well, so it's element 18. Element 18 in the periodic table is argon. Argon's atomic mass is 40 and 18. Now for D, it's an ion. Why? The number of electrons and protons, or protons and electrons, are not equal to each other. It has more electrons than protons, meaning it's a negative ion. Okay, it's a negative ion. And again, the number of proton doesn't change. So we just need to determine the 15th element in the periodic table, and that is phosphorus. Okay, so you have phosphorus, it's element 15, and its mass is 31. Okay, 15 plus 16 is a neutron. and it has a charge of 3 negative. Okay, don't forget this, 3 negative. All right. Remember, this is 6 marks. So element E, or particle E, same with particle D. They are different only with atomic number. It's 13. Atomic number 13 in the element is aluminium. So we have aluminium. And that's, we write 13 here. The atomic mass is 13 plus 14. Right? That's 27. So we write 27 here. And since there are more protons than electrons, this is a positive charge. So we get 3 plus. Positive ion. And that completes the 6 marks. Okay? That completes the 6 marks. Now for B, which atom in the table is an isotope of the atom which has the composition 11 protons, 11 electrons, and 14 neutrons? 11, 11. So particle B is the answer. It's 11 protons and 11 neutrons. Give a reason for your choice. So we can write down first particle B. Particle B. You can write down sodium as well. Why not? That's possible. Particle B, and then the reason, they have the same number of proton and or the same atomic number, and not the same. Yeah, they have the same number of protons and electrons. Yeah, same number of protons and electrons. So we can write that down. Same number of protons and electrons. I think this reason will do. Or you can say the same atomic number. It's 2 marks anyway, so we can end there. Part 3, complete the following table which gives the number of protons, electrons, and neutrons in each of the 5 particles. Alright, so this time, instead of just giving the symbol or formula, we will be completing the whole table. Okay, whole table. Alright, so first particle, the number 19. So usually just look at the number of protons and locate it in the periodic table because it determines the atomic number. So 19th is potassium. So we have K, it has 19. Now 19 plus 20 gives the atomic mass, it's 39. So it's 39. Alright, for iron, so it's written here 26, so the number of protons is 26. The number of electrons, since it's neutral, it's 26 as well. And 56 minus 26, it's equal to 30. So 30 neutrons. Okay, 30 neutrons. Element 3 is lithium. So we get lithium. And 3 plus lithium, periodic table is 7. Oh, wait. So the number of neutrons since the atomic number, the number of protons and neutrons are number of protons and electrons are not equal, means this is an ion. So lithium plus 3 minus 2 is 1. Yeah, I think that's it. That's the information that we can only give. We don't need to fill in this in. It's not known. Yeah, so there, it's a positive ion. Now we have gallium, and atomic number is 31, so the number of protons is 31. Wait. It's a positive, so 31. Yeah, it doesn't change, right? It's protons, so 31. And the electrons is 31 minus 3 is 28. So 31 minus 3 is 28. Where did I get that? Because of the charge here. Okay, just like what we did in lithium, which is this is plus, so 3 minus 2 is 1, so 1 plus. So in here 3 plus, so 28 is the answer. And the atomic mass is 70 minus 31. 70 minus 31 is 39. Yep. So the answer is 39. Now atomic number here is 34. That is 34 selenium. So selenium, it's 34, and the atomic mass is 40. 34 plus 45, that's 79. Alright, I think that completes the table. Okay. Now the next part in this video is the alternative to practical. Okay? Alternative to practical. So let's answer it. Now, two students are trying to make a model of an atom. They have different pieces of fruit. The fruit they have are apples, oranges, and grapes. The students decide to use apples to show protons. So, this one is protons. Okay, proton. Now, which fruit should they use to show the neutrons? So in this case, you have only two options. So maybe oranges and grapes. Okay, so in this, I will choose oranges. So let's say, which fruit should they use? I will use oranges. In terms of size, grapes is smaller. Yep, so based from the size itself as well, grapes are smaller, and we know that in terms of size, electrons, relative mass is negligible. So we can assume that grapes should be the electrons. So this should be our electron, and oranges should be our neutron. Okay? Neutron. Charge is plus. So which fruit should they use? So the answer here is oranges. Yep, oranges. Give reason for your answer. I just said it. Because apples and oranges have approximately the same mass. So apples and oranges have approximately the same mass. All right. Which fruit could they be used to show the electrons? I just said it. So grapes. And give a reason for your answer. Grapes are much smaller. Okay. Grapes are much smaller than apples and oranges. All right. B. One student draws a circle on a piece of paper. She places 5 apples inside the circle to show that the element she is modeling has 5 protons. State which element this proton number represents. So just find number 5 in the periodic table, and that is boron. Okay, boron. You can write B if you like, doesn't matter. Now, question 2. A student is attempting to calculate the relative atomic mass of an unknown element Q. He has the data below on the number of protons and neutrons in each of the two isotopes. Calculate the mass number of each of the isotopes and add your answers to complete the table. Okay, so 44 plus 45, that's 89. So mass number is 89. 44 plus 46 is 90. I think that's it. You just need to add them. Now for D, the abundance for each isotope is element Q isotope 1 is 55%, and the element Q isotope 2 is abundance is 45%. Using the data for the mass number for each isotope calculated in part A, and the abundance values show the relative atomic mass of the element Q, which is 89.5. It should show. Okay, so this is simple. We just need to multiply. So that's element A is 89. So 89 times 55%. So that's 55. We'll add that to 90 times 45. Yep. So this gives us 4895 plus 4050, and adding it. And we'll divide this to 100. Okay, we'll divide this to 100. Let's just put the equal sign properly. And this gives us 89.5. So again, here you can just write shown. Alright, so I think that gives us 3 marks. Thank you. So that's all for Unit 2.